When we think about nuclear power plants, we imagine that they are very well protected and guarded places, but at the same time, they are unsafe and potentially dangerous. That's because some of the worst technological accidents in history occurred at these sites, like the accident in Fukushima, where the plant was first hit by a magnitude 9 earthquake and then by a tsunami. This led to the meltdown of 3 out of the 6 nuclear reactors at the plant, causing the leakage of several radioactive substances, including 4 that are particularly dangerous: iodine 131, cesium 137, plutonium 239, and cesium 134, in addition to 270,000 tons of radioactive cooling water, which still hasn't been determined how or where it will be disposed of. From the 3 Mile Island accident, or at worst, Chernobyl. But one of the things that creates a lot of curiosity are those yellow barrels with the radioactive symbol. After all, what's inside them? What kind of things are stored inside them? Is there that green radioactive slime we see in cartoons inside them? And why do nuclear plants need them? Every human activity produces waste, and it's practically impossible not to generate waste. It's like a fingerprint left by humans, and with nuclear plants, it's no different. Nuclear plants need fuel like uranium or plutonium to produce energy. Plutonium's half-life is 24,000 years, meaning its radioactivity takes that long to decrease by half. Uranium has a half-life of 703.8 million years. Inside a nuclear reactor, there are uranium dioxide pellets stacked one on top of the other. And a pellet of enriched uranium dioxide, 9 millimeters in diameter and 10 millimeters in height, practically the same size as a bullet, is capable of producing the same amount of electricity as 22 tanker trucks of diesel oil. A nuclear power plant contains around 17 million of these pellets. But the problem is that the process of generating clean energy through nuclear fission, that is, through the splitting of uranium nuclei, produces as byproducts cesium, barium, krypton, iodine, and strontium, which are chemical elements that were not needed and later need to be disposed of. Along with them, the fuel rods containing uranium, which after some time can no longer sustain enough fission reactions and need to be disposed of. But they still generate significant radiation and heat. And that's why they are stored in special pools with a depth of 10 to 12 meters made of materials like steel, lead, and concrete several centimeters thick. And they stay there for a period of 5 to 40 years. This is inside the plant itself. The water helps with cooling and containing the radioactive material. Afterwards, they are placed in so-called dry casks, which are containment cylinders weighing between 100 and 150 tons, and they stay there for a maximum period of 40 years until the radiation decays to less harmful levels. And then they are stored in deep geological repositories for a period of 10,000 to 100,000 years. And that's the fate given to high-level radioactive waste. But nuclear power plants also require a lot of people, including technicians and engineers, especially those who work in the isolation perimeter, that is, in the areas close to the nuclear reactor, and who are required to wear the famous yellow suit, which is waterproof, hermetically sealed, hard to tear, and easy to wash, which in fact does not protect against radiation, and only serves to prevent potentially radioactive particles suspended in the air from being absorbed by the skin or sticking to the clothes. And at the end of the shift, these suits need to be discarded, along with gloves, masks, safety goggles, face shields, and foot and head protectors. And that's where the radioactive nuclear waste drums come in, which are regular 200-liter metal drums painted yellow and labeled with a symbol that represents radioactivity, also called the trefoil, meant to store low and medium-level radioactive waste. Yellow is the internationally standardized color for storing radioactively active material, but other colors are also used. In the case of medium-level radioactive waste, which usually needs some shielding but not cooling, such as resins, chemical iodine, metallic nuclear fuel cladding, laboratory glassware, contaminated material from reactor decommissioning, and some clothes and suits used during activities involving the reactor itself. These materials need to be solidified in concrete or bitumen, or mixed with an area called silica, and vitrified for disposal. One important thing is that radioactive liquid materials cannot be disposed of because they can contaminate the soil, so they must be solidified first. Only after that can they be stored in deep geological repositories, which are huge repositories made especially for this purpose, usually built on rock at depths from 200 meters to 1 kilometer, and they stay there for many years. Low-level radioactive waste comes from hospitals and industries, as well as from nuclear power plants, containing paper, tools, rags, clothing, and filters, which usually have small traces of contamination, are also placed directly into drums. Radioactive objects are then buried and can remain underground for a period of 20 to 40 years, and in some cases, even longer. Burying or storing radioactive material in large repositories has never been the only disposal option. For example, several countries have already chosen the sea as a location. Mainly, the Mariana Trench, the deepest place in the world, has already been used as a site for waste disposal. From 1943 to 1996, with more than 200,000 tons of waste in highly radioactive parts, such as laboratory glassware and even parts of nuclear weapons inside barrels. By 1991, the United States had already sunk more than 90,000 barrels in the North Atlantic Ocean, potentially polluting the water and causing irreversible damage to marine life. But the dumping of nuclear waste at sea was banned in 1993 by the London Convention. But in the 1970s and 1980s, NASA conducted several studies on disposing of nuclear waste in the sun. They would be incinerated in heat over 7,000 degrees Celsius, but the idea didn't progress far, mainly because of potential failures and possible explosions in the launch vehicle, which could spread several tons of radioactive material. Besides the cost per launch, it would take many trips to move the existing hundreds of thousands of tons of waste. And launching, be advised, stay at your consoles. Everyone in the LCC, maintain your position.
And launch team, be advised, stay at your consoles. Everyone in the LCC, maintain your